Hello everyone and welcome to Module 9. In Module 9 we'll talk about experimental designs. We'll talk about experimental designs in this module. In the next module we'll talk about non-experimental designs, primarily survey research. So let's do a quick refresher at this point about why we conduct research. It's not just because we're nosy and want to know about people's lives, although for some of us that may be true. So typically when we're conducting research, we want to describe a phenomenon, so an event, a behavior, attitudes, characteristics of a certain population. Often for many of us in the kind of work that we do, we want to intervene upon or improve some behavior or behavioral outcome. And typically, sort of overarching, we want to better understand and predict human behavior. So we want to know why people do what they do and how we can better predict what they'll do in different situations under certain conditions, typically because that will help us to better intervene upon or improve behavior or behavioral outcomes. So often this intervention or change in behavior for at least the work that we do is typically our end goal. And describing a phenomenon, better understanding and predicting that phenomenon is part of the process in getting to that end goal. And so typically we want to determine causes of some characteristic, attitude, behavior, or event. And causal effects are defined as variation in a dependent variable or an outcome variable that follows variation in the independent variable, all other things being equal. The reason I have the asterisk there is because we know that we're never going to design something or never be able to understand or know if all other things are equal. But we do our damnedest. So that's what we'll talk about in this module, is trying to help us design better experiments to be able to better determine the causes of behavior and to understand and predict human behavior. So when we're talking about causation, we want to talk about primarily 3 criteria of causation, but I'll talk about 5 criteria of causation. One is when we're talking about the relationship between an independent and a dependent variable. Those variables have to be correlated. And you've all probably heard the mantra, correlation does not equal causation. So just because 2 variables are correlated, and what that means is an association between the 2 variables and that 2 variables vary together. So just because they are correlated doesn't mean that one causes the other. And typically when we're talking about correlation, we often talk about negative or positive correlation. Those are the 2 ways in which variables can be correlated with one another. In a negative correlation, when one variable goes up, the other one goes down. So for example, we would say if contraceptive self-efficacy, or the confidence that you have in your ability to effectively use contraception, as that increases, your risk behavior decreases. And in a positive correlation, we could say when one variable goes up, the other one also goes up. So we could talk about knowledge, for example, knowledge of appropriate sexual safety behaviors, and so as knowledge increases, effective use of contraception increases as well. But correlation does not necessarily mean that one causes the other. In each of those examples, we could think about them as causal, but we don't necessarily know that they're causal unless we design our study in a way to be able to test that. We can suppose or make assumptions that there is a causal association there, but there may be something else that's happening there, and so we can't necessarily conclude causation. We also have to have temporal priority of the independent variable. So we have to know that the independent variable happens first. So if we think about the example from before of contraceptive self-efficacy, so the confidence that you have in your ability to effectively use contraception, that confidence may actually be built by effectively using contraception. So the more that you use it effectively, the more confident you are in your ability to use that effectively. And so we don't necessarily know which one of those variables comes first. They probably work in tandem with one another. And so when we're designing experiments, we often want to say that the independent variable, the thing that we're manipulating, happens or comes before the dependent variable, or the measurement of that dependent variable anyway. And we also want to know that the association between the 2 variables, the independent and the dependent variable, is non-spurious. And that is a fancy way of saying that we think that the relationship between the two variables, the cause and effect, are directly related, and that there's not some third variable playing a role, or third or fourth or fifth variable playing a role in there, that is actually what's creating the cause and effect. And so we'll talk about some examples of that as we move forward. So those are the three primary criteria of causation. What can strengthen our claims of causation are also understanding the mechanisms of that causal effect. So why and how does the independent variable have its causation or causal effect on the dependent variable? And we can try and investigate ways in which we think that relationship works to be able to strengthen our claims of causation. And we also should understand the specific context of the causal effects. So under what conditions or for whom does this causal relationship happen or work? So the three primary criteria of causation are correlation, temporal priority of the independent variable, and knowing that there is not a third variable that is causing the association that we see. And we can strengthen our claims of causation by knowing the mechanisms of the causal effect and the specific context of causal effects. And so experimental designs involve the researcher actively manipulating factors, manipulating our independent variables. And this facilitates control of our variables of interest, so we can isolate cause from effect and control for those extraneous factors that may be creating spurious results for us. And so in experimental designs, we're often thinking about laboratory designs versus field designs, and we'll talk about some examples of that moving forward. And experimental designs are our best designs for testing causal hypotheses. So if we want to know cause and effect, the experimental design is the way to go. We can make some assumptions about cause and effect with non-experimental designs, but if we really want to make a solid claim about causation, the experimental design is the way to go. And there are a lot to choose from, as you see from your textbook, and that's certainly not all of them. There are entire textbooks that are written about experimental designs and varying those designs and combining them. And so there's a ton to choose from. And your decision should always stem from your research question, but are also constrained by ethical, practical, and financial considerations. And so I'll talk about the experimental designs that your book talks about. We'll run through those fairly quickly because I think your book does a pretty good job of explaining what those are. We'll talk a little bit about some of the advantages and disadvantages of each design. And so your book outlines this notation. This notation is originally from Campbell and Stanley. There are a series of textbooks, Shadish, Cook, and Campbell, Campbell and Stanley. They're three old white dudes in the 60s who really developed a lot of our protocols and our standardization of experimental designs, at least in the social sciences. So we'll run through this notation fairly quickly. Your book has this. When we're talking about X, we're referring to our independent variable, our treatment or manipulation. X2 or Y are additional independent variables or treatments. O is always our observation or our measurement of our dependent variables. R is for random assignment. And when we're talking about X's and O's in a horizontal line, we're indicating the same group or people who are being exposed to the treatments or the independent variables and are being measured. X's and O's that are in a vertical line are things that are happening simultaneously in time. And parallel rows separated by a dashed line indicate non-equivalent groups. And so hopefully that will be clear as we talk through each of these designs. And left to right indicates temporal order. So much like we read things. So let's run through really quickly a few definitions before we jump into the meat of these experimental designs. Hopefully these are fairly obvious to you, both from your knowledge of research more generally and from your reading. But experimental groups are the groups that get your manipulation, your intervention, your treatment. Control groups are groups that do not get your intervention or manipulation or treatment. It's really important to think about what they do get, and we'll talk about that a little bit at the end of the lecture. Random assignment is a really key feature of true experiments in particular, and random assignment is a key feature of being able to make causal claims. Randomly assigning participants to your comparison group such that once you have a sample of people, or as your sample is recruited and enrolled into your study, you randomly assign them to get either the experimental or control, or if you have multiple groups, randomly assign them to each of those groups. This is a way to control for or randomly distribute pre-existing differences We wouldn't want to let people choose what kind of intervention that they get, because their choice of that intervention may actually be what's creating the differences that we see in our outcome variables rather than the intervention itself. So random assignment is a really key piece of being able to make causal claims, and therefore is a key piece of true experiments. In some cases, we may not randomly assign people, but we may match them. So we may find a comparison group that is equal in some way to our treatment group, either at the outset of an experiment or finding a comparison group later on to be able to run analyses compared to a group that is very similar in other ways to the group that you have exposed to your treatment. And post-test and pre-tests, we'll talk about these a lot, but your post-test is the basic measurement of the outcome after the experimental manipulation. All experiments have a post-test. Pre-test is the measurement of the dependent variable and often a whole range of other variables for both the pre-test and the post-test. But the pre-test is a measurement of those variables before the intervention or manipulation. In some cases, this is not required, because if you're randomly assigning people to your conditions, you can assume that they're all going to be the same on all of your variables, that whatever variation is in your treatment group is the same in your control group because you randomly assigned them to those groups. But sometimes that's not true. Sometimes you randomly assign people to both of your groups, and it turns out that one group ends up being significantly older than the other group, just because that's how the random assignment worked out. Or maybe they're higher in one of your key variables than the other group is. And so being able to measure all of your variables before you actually implement any of your intervention or treatment is a good check on the effectiveness of your random assignment. So let's talk about some experimental designs now. So we'll have pre-experimental designs, experimental designs, and then quasi-experimental designs. Your pre-experimental designs are your one-shot case study design. So this is a situation in which a group gets a treatment. This is the X variable, and then you observe them. So you expose a single group to a treatment, and then you measure them. There's no randomization, there's no control group, there's no pre-testing. A one-group pre-test post-test design is a similar situation, but you have here two observations. So a pre-test, then your treatment or your manipulation, and then a post-test measure. A static group comparison is a situation in which you have two different groups. You have one group that receives the manipulation, one group that does not receive the treatment or manipulation, and then you observe each of those groups. So you have no pre-test, but you have this post-test here. So a comparison group that does not receive the treatment, or in some non-equivalent group design, the other group receives a different kind of treatment. And some advantages of these designs are that they're good in situations where ethical or practical issues may prevent differential treatment, so intact groups, for example. And they're also good pilot tests if we're just looking for a signal. Maybe we're trying something really new, and we just kind of want to get some sense that maybe this works before we design a big, involved, true experiment, before we sink a bunch of money and time into something. Maybe we just want to try it out and see if there's any sort of a signal here. This could be a situation in which we're also doing some sort of feasibility or acceptability trial. When we talk about randomized control trials, typically we're looking at efficacy. So did it work in a controlled situation? And I'll talk a little bit more about that in a few minutes. But we also want to know feasibility and acceptability. Can I even do this intervention? Is it possible? And do people like it? So those are two really important features that you should know before you sink a bunch of time and money into testing the efficacy of your intervention, because if you can't do it and people hate it, it's not going to be efficacious. Disadvantages of this design are that it does not account for extraneous variables, it doesn't involve random assignment, so you can't make any causal conclusions here, and there's no pre-testing, so you can't account for pre-existing differences or factors that may be pre-existing that impact your outcome variables or your dependent variables. In true experimental designs, true experiments involve at least two comparison groups, an experimental group versus a control group, which establishes that correlation or that association between your independent and your dependent variable. They involve variation in the independent variable before assessment of change in the dependent variable. So again, establishing that temporal order that's important to make claims of causation. And they involve random assignment to the two or more comparison groups. And that helps us to establish non-spuriousness. So it helps us to feel certain, or somewhat certain, that there's not a third variable that we don't know about that's different between the two groups that's causing the difference that we're actually seeing. So there are a ton of true experimental designs. We'll talk about the ones that your book talks about, but just know that there are a lot of these, and there are entire textbooks written about them. So a post-test only control group design. This is what this looks like, and this is straight from your book. So this is, behold, randomization. So this facilitates equivalence in our groups before we conduct any sort of manipulation, intervention, treatment. And this controls for potential confounding effects of a pretest, because we're not actually conducting a pretest here. So we randomize our participants to one of two groups. This is our treatment group, and this is our control group, in which they're not receiving anything. And then we observe them. So we're not having any confounding effects of a pretest in this situation because we're not conducting one, but our subjects are randomly assigned to groups. The pretest post-test control group design is very similar to this, except that we're conducting a pretest. So we have over here randomization to two different groups. We do our first observation, which is our pretest. One group receives an intervention, the other group does not. And then we measure them all again. So pretest, post-test, control group design. And this has random assignment, pretest and post-test, controls for many of the threats to internal validity, which we'll talk about in a moment and your book talks about in depth. And it allows for pretest comparison, so we can make sure our randomization worked and that our groups are actually equivalent, and that we can measure any pre-existing differences or factors that may impact our intervention, the effects of our intervention. There are potential pretest intervention interaction effects here. So reporting on the pretest affects how we behave, or affects how we report on the post-test, depending on what kinds of measurements we're using. So if we're using knowledge measurements or any kind of measurements where people can learn how to respond better to those tests. So there are some issues potentially with this design still. The Solomon four-group design is a fairly involved design. This is a design in which there's random assignment to four groups. Pretest and treatments are varied, but all groups receive a post-test. And this allows for comparison of treatment to control, and it also allows for the examination of pretest effects. Two of these groups receive a pretest, two of these groups do not. You have an intervention group and a control group, an intervention group and a control group. And so you can look at both treatment versus control effects, as well as the potential effects of pretest. So testing people, asking people all the same questions prior to asking them those questions again. So this is a fairly strong design. We can examine interactions between pretests and treatments. This can be logistically and statistically challenging. There are better and better statistical methods now, and so this isn't as statistically challenging as it perhaps used to be. This still can be somewhat logistically challenging. We have to have enough people in each group to be able to have enough power to examine effects. So this involves recruiting and enrolling a lot of people into our trial when maybe we wouldn't need nearly that many people to actually test the effects of some sort of intervention. And so the last design that we'll talk about is factorial or multivariate designs. So this is a situation in which we have randomization here, but we're examining two or more independent variables simultaneously. So independent and combined effects on our dependent variable. And so we see here that we have observation here, we have randomization, we can examine treatment to control, but we may also be putting in other kinds of independent variables. There are other kinds of treatments in here, and so we can examine different kinds of groups. Your book gives an example of different kinds of letters that that an employer can send to their employees to get them to get involved in a health center. We can think about this. There's been some research, for example, on purity pledges. Some of you probably have heard of these. So this is pledging your virginity until marriage. And there's been some research that's looked at the effects of pledging your virginity publicly versus pledging your virginity privately. And so we could look at the effects of the pledge itself, so pledging your virginity, and then pledging publicly and pledging privately. So these are two independent variables, pledging or not pledging, and public or private. And so we can examine the effects of multiple variables here on our dependent variable. Probably many of you have heard about randomized control trials, randomized clinical trials, as they're sometimes called. This is a fairly standard looking flowchart. This is from a website that is involved in designing and evaluating randomized control trials. And so this is a pretty typical way that we think about conducting. This is a flowchart of how we move through time in a randomized control trial. So in the enrollment stage, we assess people for eligibility in our trial. We always want to make sure we know who was included and who was not included. And then we examine the number of people who are randomized. So who was randomized to our intervention, who was randomized to multiple interventions, to control group, for example, who actually received the intervention, who did not receive the intervention, and why didn't they receive the intervention. And then following up. So people who were lost to follow-up, who dropped out of our trial, who dropped out of our trial after they received all of the intervention, perhaps, or who discontinued the intervention. And then an analysis, who we included and excluded from our analyses. Were there people that we decided ultimately were not part of our population of interest or didn't get enough of the treatment to be able to examine the effects, or an outlier in some way. And so these are the gold standard of clinical trials. They involve randomization to the group, they involve pre-test and post-test, and they can help us understand efficacy or effectiveness. And these are two different terms that are used to assess essentially the same thing. Did an intervention work? When we talk about efficacy, we talk about whether or not that intervention worked in a trial setting or a laboratory setting. And if we talk about effectiveness, we talk about whether or not intervention worked or had the desired effects in an actual practice setting. So a medical setting, a school setting, something like that. These obviously can be fairly expensive and labor intensive. It's sometimes why we do a pilot study or do feasibility and acceptability studies before we actually conduct an entire intervention. We want to know that our intervention is really good and sound before we go to all the work to test the efficacy of it. So often we can't design an experiment, we can't conduct an entire experiment for a whole variety of reasons, ethical reasons perhaps, practical reasons, often time reasons, a lot of logistical reasons. And so we conduct quasi-experimental designs. These do not involve randomization typically. They typically don't involve control groups, and there are still a variety of design options within quasi-experimental designs. So one of them that your book also talks about is interrupted time series designs. And so this is a situation when you make multiple measurements of the same thing and then implement your intervention or manipulation and then make multiple observations of the same thing again. In this kind of design, we have to think about maturation effects depending on the timing. So if we're conducting each of these observations fairly close in time, so maybe like once a month, and then we do our intervention and then conduct these observations once a month again, then we're looking at an 8-month time period, and maybe not a lot of maturation might occur in that time period depending on the age of our sample. But if we're conducting each of these every 6 months, for example, and then we do our intervention and then conduct these observations every 6 months again, particularly if we're talking about adolescents, young adults, a lot can happen between this first observation and this last observation that may have nothing to do with our manipulation. So we have to think about the maturation effects, which we'll talk about again in a few minutes when we talk about threats to validity. We also have to think about how multiple measurements of the same thing may impact the responses to that test and may potentially impact behavior as well. The equivalent time samples design, this allows for multiple interventions to be tested. So implementing one intervention, doing an observation, implementing another intervention, doing an observation, etc. Your book mentions, and I'll mention again, that there's nothing magic about the 4 observations here or the 4 interventions and observations that go along with here. This is just the example. You could have 2 or 6 or 10. So in this situation, in the equivalent times design, the example that your book gives, I think, is the snacks in the morning or the breakfast in the morning, and then student behavior. So in that situation, you have to think about the impact of each of these interventions on the observation at that time period, but then the impact of this intervention on this time period and this time period and this time period. And so one way to try and control for that, or try and move around those effects, are counterbalancing this design. I didn't put this design from your book in here, but you can look at that on page 189. And this is when the groups are exposed to treatment conditions in a counterbalanced order to control for the effects of exposure on response to subsequent treatment. So whether it's learning effects, comparison effects, one of the things that you can think about with the example that your book gives. So on some mornings they're given bagels, on other mornings they're given fruit maybe, or something healthy. And so kids may say, like, wait a minute, we got bagels this time and now we're getting fruit. I hate this. I'm going to be a jerk in the morning and not behave very well because I want to go back to bagels. And so if you say some kids get bagels first and some kids get fruit first, and balance the design of that, you can try and control for some of those comparison effects, and those will wash out, those will come out in the wash in your analyses. Or learning effects, if you're going to expose people to different kinds of interventions over time, and they may learn something from this intervention and learn something else from this intervention and learn something else from this intervention. And so that by the time you get here, this intervention looks incredibly effective because you have the cumulative effects of everything that they've learned here. And so if you say some people receive this intervention first, some people get this one first, some people get this one first, etc., you can counterbalance the effects that you see of any learning or comparison effects. And then finally, we'll talk about non-equivalent control group designs. This is very similar to a true experimental pretest post-test design, but without randomization. And so sometimes, as your book points out, that's impossible or unethical. If you have intact groups, for example, you can't necessarily randomize each of the kids in a school to get a particular design or a particular intervention. So this is the same thing where you pretest everybody. Some people receive your intervention, some people don't. They're in the control group. And then everybody gets that post-test observation. So in all of these designs and all of the pre-experimental, experimental, and quasi-experimental designs, we have to think about both internal and external validity. Internal validity refers to the truth in your conclusions of causality, if you're making those, or the conclusions that you're making about the relationship between two variables, even if you're not saying that it's a causal relationship. And so there are a variety of threats to internal validity. Your book lists a nice little summary box of these, and I'll talk about each of them very briefly. So one threat is history effects, so external events that happen during the experiment. Typically we're worried about events that happen between our pretest and our post-test, or between our manipulation and our post-test, for example. So major events in the news, things that may have come out that may be different kinds of contraception, or a new public health concern that's come out. For example, some of the things that a lot of HIV researchers are looking at right now is when the availability of PrEP, or pre-exposure prophylaxis, happened in the middle of a controlled trial. So people who are examining, for example, the effects of their intervention on condom use, and suddenly PrEP becomes available, and maybe people are stopping using condoms because PrEP is available to them, or they're changing their decision-making about sexual risk behavior in some other way because of PrEP. So that's an external event that may impact the results of our experiment. Maturation effects are when participants get older and more mature, and thus the outcomes change. So for example, knowledge or perhaps confidence in one's behavior as you engage in that behavior more and become more mature. That will change on its own and won't have any effect, won't be impacted in any way by your manipulation necessarily. Testing effects, this is when pre-testing impacts post-testing. So you may just know how to answer a test now, you may remember the answers. You may just get better at taking that kind of test. Instrumentation validity, we talked about during instrumentation. This is when your instruments are not valid in some way. And so this also impacts our internal validity, our ability to make some claim about a relationship between two variables. Selection bias is when we have some non-random selection of participants that may impact the claims that we can make in some way. Selection maturation is when maybe you have group-specific differences in maturation. So maybe your control and your experimental group are different somehow, probably because you didn't randomly select them. And so maybe they mature at different rates or in different ways. Statistical regression, or what's called regression to the mean. This is a tendency for scores to regress towards the mean. So when you measure them one time and then you measure them again, they tend to regress towards the mean. And this refers to the reality that high scores can only go down, low scores can only go up. And so are the changes that you're seeing real changes that are impacted by your independent variable, or are they just the natural movement of scores? Mortality and attrition effects are due to death or discontinuation of participants. And so you may have differential attrition, for example. If everybody hates one of your conditions and drops out, then you're going to have a hard time establishing some relationship between two variables, between your intervention, for example, and your outcomes, if everybody in one group quit and fewer people in the other group quit. The Hawthorne effect, your book talks about, is changes in behavior because you're observing or monitoring your behavior. So maybe this is a situation in which you're doing a daily diary, for example, and so every night you're writing down the sex that you had and whether or not you used a condom. And so you're very aware that you're actually writing this down and you're going to have to report this every day. And so maybe you start using a condom more because before you didn't have to tell anybody whether or not you were using a condom, and now you do. And so your behavior's changed because of observation, but not because of the intervention. Placebo effect, you're likely all familiar with. This is changes in behavior because you believe that some intervention is going to have an effect on your behavior. This is more common in medical research, pharmacological research, for example. So I take this pill and I believe that it's having this effect on me, and lo and behold, I see this effect on me. And so it's not because of the pharmacological effects of the pill, but it's because of your belief of the effects that that pill will have. Diffusion effects are particularly tough to deal with. These are often when the treatment effects, or the treatment that you're giving, for example, to the intervention group or the experimental group, spills over into your control group. And this often happens when you are conducting intervention research in a single setting or among a group of people who are all connected to one another. This is something that I have commonly dealt with in HIV intervention research, working with HIV positive participants who are all connected to care, and we're often recruiting them from AIDS service organizations. And so some of them are randomized to the treatment group and some of them are randomized to the control. And in some cases, you may have people who are dating, who are married, who are very close friends, and one of them is in your treatment group and the other one's in the control group. And let's say, for example, we have a husband and wife, and the husband is in the treatment group and the wife is in the control group, and the husband comes home and says, "You should see all this great stuff I learned. Let me teach you all the stuff that I learned." And so we actually have a situation in which our control group is indirectly receiving our intervention treatment. We also have location effects, so the context of the intervention may matter. So we want to think about whether that context is the same across all of our groups, or if that context matters in the effects that we're seeing and the relationships that we're seeing. And then we can have implementation effects. So these are interventionist effects. So maybe we're not seeing the effects of the intervention itself, but we're seeing effects of people who deliver that intervention. And then we have external validity. This is often what we refer to as generalizability. This refers to the ability to generalize the results to the real world. So if we're conducting a randomized controlled trial, for example, in a research setting, in a research center that's separated from medical care, separated from service organizations, can we then take that intervention and put it into real world settings, and will it have the same effects? So there are a variety of threats to external validity as well. So is our sample actually generalizable to the population that we're interested in? So if we're talking about HIV medication adherence research. Are the HIV positive people that we are actually including in our sample similar to HIV positive people in general, or in New York City, or Philadelphia, or whatever? We also have to think about cross-population generalizability. So is the sample that we collected similar not only to the population from which we drew them, but to other populations as well? And does that matter to us? Is that something that we're concerned about? Do we want to be able to generalize our results to other populations or just to our population? So for example, in HIV medication adherence, would we only want to generalize our results to other HIV positive folks and think about HIV medication adherence, or would we want to generalize our results to all sorts of medication adherence, like diabetes medication adherence or hypertension medication adherence? We also want to think about potential interactions of testing and treatment. So for example, our intervention may only have the effects that we find in our trial when it's combined with pretesting and monitoring of behavior. So without that other piece of the procedure, maybe we actually don't see the effects that we saw in our trial in a laboratory or research setting. And we also have setting by treatment interactions. So maybe our intervention only works in a very narrow setting and can't be duplicated in the real world. So for example, maybe we're only seeing the effects of our intervention when it's conducted by people who are not part of people's care or not part of a social service agency. So when we actually implement that intervention there, maybe it doesn't work in the same way that it does when we're doing it in a very different setting. So before we end, I'll talk about some miscellaneous design issues and then summarize some of these issues more broadly. So as we talked about when we were talking about threats to validity, we also have to worry quite a bit about fidelity to protocol. So we want to have clear and specific protocols for our interventionists and our assessors. We want to make sure we train them very well and continue to monitor and supervise their implementation of our intervention. We have to have attention to personal biases, styles of interventionists, the ways in which they're implementing that. And we should really review our intervention delivery. So in many cases, the work that I've done, we've filmed the staff. So you only hear the participant's voice, but we can actually review either randomly or systematically in some way the delivery of the intervention. And I've actually conducted some research where we've rated the adherence to a specific intervention protocol. So many of you may have heard of motivational interviewing. It's a style of therapy, and we've used it in a lot of intervention work that I've been involved with. And there's something called motivational interviewing treatment integrity, and that's a coding system to be able to determine if people are conducting motivational interviewing in the way that it's supposed to be done. So you can actually review your interventionist and find out if people are maintaining fidelity to that protocol. You can also ask your participants what they thought about the interventionists, what they actually did in that situation. As I mentioned in the beginning, the control condition does matter. It impacts the conclusions that we can make from the comparisons to the treatment groups, and also involves some ethical considerations as well, particularly when we're conducting health research. There are a lot of ethical things that we have to think about. So one of the ways in which we can try and design better control conditions is by conducting attention control groups or designing attention control groups. And so one of the thoughts about this is that if you're bringing people in for an intervention and then the other group is just getting nothing, you don't necessarily know that the effects that you're seeing in the intervention group are just because you paid attention to somebody. So maybe it's just that they had somebody to talk to, that somebody was asking them about their behavior and their lives, but the content of your intervention didn't matter so much. It was just that you were paying attention to somebody. So attention controls allow you to pay attention to the control group. So maybe that's delivering something to them, but without the content of the intervention. So finding the pieces of your intervention that really matter and only including those in the intervention group and giving the control group something else. We have sometimes done videos. So just coming in and sitting with a staff member and watching videos that are somewhat informative and instructional, but don't have the content that the intervention does. Waitlist control is also a popular design. So this is saying everybody's going to get this intervention eventually, But for right now, in sort of the reporting period, or the time between our first pre-test, our baseline assessment, and our post-test, the people in the experimental group will get our full intervention. The people in the control group will not get it. They'll get a post-test, but then they'll go ahead and get that intervention later, particularly if we find it to be efficacious in helping with some behavior or behavioral outcome. So this can get around some ethical issues with withholding a potentially effective intervention for some people in your population. Often we talk about standard of care interventions. So this is something I've also worked with in HIV research. So if we know that in HIV care situations, people are getting, a 20-minute talk with their doctor about how to engage in safer sex or negotiate safer sex practices with their partners, then we should definitely do that, because that's what they would get out in the world, and that's what we want to compare our treatment to. So is our treatment any better than what they're already getting out in the world, than what they would already get if they were to go to their doctor or a social service agency, something like that? Or nothing. We just want to give them nothing and be able to compare our treatment group to not getting anything at all. So these are all decisions that are ethical, practical considerations, as well as considerations related to our research question and the components of our intervention that we're interested in testing. Retention is a huge issue. You see the parts in the flowchart that I showed you with randomized controlled trials about who was lost to follow-up. So we want to try and do a variety of things to keep people in our study through the entire pre-test to post-test design. So giving them money, appropriate money, is a key piece, while making sure that that money is not coercive in any way. Potentially we're giving them services or access to services. We also want to make sure that that's not unethical in some way or coercive in some way. One of the best things we can do is help keep people engaged in our intervention. So if they like it and they want to come back, then they will, and that's amazing. And in thinking about our baseline and post-test assessments, we want to make sure that we're measuring both constructs, both times, often in the same way, or if we're worried about pre-test effects, in ways that we can compare still if we're using different measures. We want to avoid the interventionists themselves asking people the questions. For example, if you sat and met with a therapist every week for 4 weeks, and then that therapist came in and asked you about your sexual risk behavior when they've been trying to get you to be safer for the last 4 weeks, the person might be more likely to say that they've been being safer because they don't want to disappoint their therapist. They want to tell them what they want to hear. We often talk about blinding data collection, so randomizing people to our groups after their baseline, and making sure that the research staff who conduct the post-tests are blind to what condition people were in. That's sometimes possible and sometimes not possible. We can also ask people about the self-perceived impact of the intervention and their experience in the intervention. So again, this acceptability piece. Did you like it? Do you think it worked? Would you do it again? And again, blinding to conditions. So there's limits to how much we can blind sort of the individual participants to the condition, the extent to which we can do double blinding, where the researcher is blind to condition. That can sometimes work and sometimes not work, depending on staffing and our context in which we're conducting research. So John Cresswell is an education researcher, does some health research as well, and has written a variety of methods, textbooks, has an experimental design checklist that I'll run through fairly quickly here, but you have it on this slide now. So when you're designing experiments, we have to think about who the participants are, who's eligible, what are the inclusion and exclusion criteria, what's the population to which we want to generalize our results, how will participants be selected, will that be random selection or not, and will we randomly assign people to group? If not, will we match people either before or after our intervention? How many people will be in each group? That's related to statistical power. How many do we need in each group to be able to actually test the effects and find statistical significance? We'll talk a bit more about that later on in the semester. What's the dependent variable? How will it be measured? Will it be measured before and after? Do your measures have established reliability and validity? What's the treatment condition? How's it operationalized? What are the key components of that intervention or that treatment that you think are particularly effective? Is it based on the literature? Is it based on theory? Are there variables that you will covary and will try and measure in addition to your independent and dependent variables, and how will they be measured? What design will you use? So all the experimental designs we talked about are just one piece of our overall experimental design checklist. What are the steps in the procedure? So will we recruit people first, then randomly assign them to groups, then conduct a baseline assessment, etc., etc. What are the potential threats to internal and external validity, and how will they be addressed? Will we conduct a pilot test? Will we conduct feasibility and acceptability trials before our efficacy trial? How will we analyze the data and interpret those results? And then what conclusions will we make? So how will all of this information impact the conclusions that we can make once it's all said and done? And so when we're evaluating experimental and quasi-experimental research, we want to think about the quality of the intervention. So is it acceptable to participants, to people, clients, adolescents, what have you? Is it feasible? And is it feasible both in a lab situation and out in the real world? So sometimes we conduct interventions that are delivered by PhD level clinical psychologists. They involve 16 hours of intervention. And then we conclude, in fact, that it's efficacious and it works. But in most social service settings, in most medical settings, we don't have 15 different clinical psychologists who can spend 16 hours per participant to create that kind of an intervention. So is it feasible to conduct out in the real world? Is it theoretically based and grounded in research literature? And is it strong enough to enact some behavior change or affect some behavioral outcomes? We also want to evaluate the evaluation of the intervention. So these are some of the methodological decisions, the design decisions. Is the sample size big enough to find an effect? Or is it so big that we're finding effects all over the place? Is our measurement psychometrically sound and appropriate to the goals of the intervention? So are we actually measuring the thing that we think that we're changing? And do we have internal and external validity? So this is a sort of a checklist for the evaluation of intervention work or experimental work. So hopefully at the end of this, you are aware that choosing an experimental design or choosing a research design more generally involves a lot of factors. So the research question is the most important factor. What is it we really want to know? Do we want to examine a causal effect, and is that even possible? Ethical issues, can we address our question, or how can we address our question without violating any laws or harming any participants? What type of study can we afford, and what's our source of funding, and what do they want? Feasibility, so how likely is it that you can carry out our design in a laboratory setting or a controlled setting and in the real world? And then do we have access to our study population? So who or what are available for us to study? And so in summary, all of the research designs, including experimental designs, have strengths and weaknesses. It's important to realize these when we choose our design and when we discuss our limitations in our final work. And it's really important to have a well-defined research question. So we'll talk a lot more about research questions, and we have talked a lot more about research questions, but these are really the key piece of any research that we're conducting, and they should be the most important factor in choosing our design, in making conclusions. All the decisions we make as we're conducting research should really stem from our research question. So I'll end it there. As always, if you have questions or thoughts, post these under the general discussion forum. Thank you.